Today we are going to be working on the inverse of our trigonometric ratios. So yesterday we talked about how to find the sides of a triangle using trigonometric ratios. Today we're finding the angles. So remember that when you put sine of 30 degrees in your calculator, so let's go to our calculator. Remember that we need to check our settings. So we're going to go to settings, which is 5, and then document settings, which is number 2, and angle. So notice that I'm in the wrong format. I need to be in degrees, and then make it your default and say OK. So new document, I want a calculator, and I'm going to use the trig button over here under control, and I want sine of 30 degrees. And since I'm in degree mode, I don't need to put the degree sign, and I get 0.5. So the converse of that is if you have an acute angle and the ratio is 0.5, then you know that the measure of the angle is 30 degrees. So the sine inverse of 0.5 is 30 degrees. So again, your calculator has to be on degree mode. You need to make sure you check that before you do anything else. And if you don't have a Inspire, you need to make sure that whatever calculator you have is in degree mode. You can check it by typing in sine of 30 degrees and getting half, or 0.5. So that's what we're going to do on the first set of examples. We're going to use our calculator to find the measure of each angle, and we're going to round to the nearest degree. So nearest degree means that we're rounding to the nearest whole number. So we're going to type in cosine inverse, because that's what that little -1 means, of 0.5 in our calculator. So press the trig button, and cosine inverse 0.5, and that gets us 60 degrees. Going to go ahead and type sine inverse of 0.45 in our calculator. So again, press the trig button, go down to sine inverse, and it was of 0.45, and that gets us 26.743. So when we are rounding, we're looking at that number after the 6, which is a 7. So it's greater than 5, so we're raising the score. So that becomes 27 degrees. Then we're looking at the tangent inverse of 3.2. So press the trig button, here over and down, tangent inverse of 3.2. And we have 72.646. Again, the number after the decimal place, this in case it's a 6, it's greater than 5, so we're raising the score, so we have 73 degrees. Just like yesterday, we need to label our triangle. When we're labeling our triangle, always start with your hypotenuse, because that one doesn't change. So across from our right angle is our hypotenuse, and that in this case is AC. And the first angle we're looking for is angle A. So we're going to label from angle A. So next to angle A is the 7.5. That means that's the adjacent side for angle A. And that leaves us with the 5 being the opposite for angle A. Now, when we are dealing with trigonometric ratios inverses, we need two sides of the triangle that have numbers. And our two sides that have numbers are our adjacent side and our opposite side. So what uses opposite over adjacent? That is tangent. So we're going to take the tangent inverse because we're finding an angle measure of our opposite, which is 5, over our adjacent, which is 7.5. So tangent inverse 5 over 7.5, that's what we're going to type in our calculator. Press the trig button, or down and over, and go ahead and do your control divide, 5 over 7.5. And we get 33.69. Again, we're rounding to the whole number. We have a 6 in the tenths place, so that rounds up to 34 degrees. Now at this point, you want to double check that you have, one, got the right trigonometric inverse that you used. So we need to look and say, okay, we've got adjacent and opposite again. Make sure we have our triangle labeled correctly. Our adjacent's the one next to our angle, opposite's the one across from it. So we do. We have opposite over adjacent, which is tangent. Use our inverse, plugged in. We're good. Okay, because angle A is 34 degrees. Now to find angle C, all we have to do, add our two angles that we know now. So 90 plus 34 gets us 124 degrees, and subtract from 180. And that gets us 56 degrees for the measure of angle C. Now, you'll notice why I said that you need to double check your first one. It's because if your first one is wrong, that means the second one in that triangle is also wrong. So make sure you go back and double check your work. On our next triangle, again, label your hypotenuse first. Our hypotenuse, again, is always the side across from our right angle. And that gives us DE as our hypotenuse. And we are looking for angle D first. So that is our X. That's what we're looking for. Next to that angle is our adjacent side. Across from it is our opposite. Again, remember that we need two sides with numbers on them. And our two sides with numbers on them are our adjacent and our hypotenuse. And what trigonometric ratio uses adjacent over hypotenuse? Cosine. So we're going to take the cosine inverse, one with a -1, of our adjacent, which is 3.2, over our hypotenuse, which is 6.8. And we're going to go ahead and plug that in our calculator. Cosine inverse of 3.2 over 6.8. And we get 61.9275. We have a 9 in the tenths place, so we are rounding up. So we have 62 degrees. Again, double check that you set this up right. Across from our right angle is our hypotenuse. Next to the angle we're looking for is our adjacent. Across from it is our opposite. Our two sides with numbers on it are our adjacent and our hypotenuse. And adjacent over hypotenuse is cosine. 3.2 over 6.8. We're good to go. So now, to get the next angle, take and add that 62 to 90. and then subtract what we get from 180. And we get 28 degrees for the measure of angle E. Okay, so again, anytime you are finding the measure of an angle, you are using the inverse. Yesterday we talked about using just the trigonometric ratio to find the length of a side. So again, we need to label our triangle. Again, across from our right angle is our hypotenuse. This time we have an angle given to us. It's the 58 degrees. So the side next to that 58 degrees is our adjacent. The side across from the 58 degrees is our opposite. And our first example here, we are looking for EF. EF is our adjacent and we don't know it, so that becomes X. And we need to decide that we have information about. The only side we have information about is our opposite. So we have opposite and adjacent. What trigonometric ratio is opposite over adjacent? It's tangent. So we're going to take the tangent of our angle measure, so tangent of 58 degrees, over 1 equals our opposite, which is 14, over our adjacent, which is X. Again, remember that you need the side that has information on it and the side you are looking for. And using the information we have, opposite and adjacent, that tells us which trigonometric ratio to use. Then we're going to cross multiply. So we have X times the tangent of 58 degrees equals 14. And then we're going to divide by the tangent of 58 degrees. So X equals 14 over the tangent of 58 degrees. And we're going to take that to our calculator. So control divide, 14 divided by the tangent of 58 degrees. I don't need the degree sign because we're in degree mode. I know we're in degree mode because it says degree up in the right-hand corner. Press enter, 8.74817, and we are rounding to the hundredths place. The hundredths place is the second place after the decimal, and what's after that is an 8, so we are raising our score. So we have 8.75. Our next example, we are looking for DF. So we are no longer looking for our adjacent. We have our adjacent now. We're finished with our adjacent. So now we're looking for our hypotenuse. So that's going to be Y. And we need our hypotenuse and the side we originally had a number on, which is our opposite. Do not use the 8.75. That is something we found and rounded. It will not give you an exact answer. So always use the information that was given to you in the problem. So we have opposite over hypotenuse. What is opposite over hypotenuse? It is sine. And we take the sine of our angle, which is still 58 degrees, over 1, because we always put our trigonometric ratio over 1, equals our opposite, which is 14, over our hypotenuse, which is Y. Again, cross multiply. So we have Y of times sine of 58 degrees equals 14. Then we're going to divide by sine of 58 degrees. And that gives us y equals 14 divided by sine of 58 degrees. And we're going to go and put that in our calculator. 14 divided by sine of 58 degrees. And we get 16.5085. Again, we are rounding to the hundredths place, which is that 0. The number after it is an 8. So again, we are raising our score. So 16.51. Our next example, again, we need to label our triangle. Across from the right angle is a hypotenuse, so that's the 15.3 is our hypotenuse. We have an angle given to us, that 26 degree. The side next to it, that's not the hypotenuse, is our adjacent side. And the side across from that 26 degrees is the opposite. Our first one here, we're looking for XZ. XZ is our opposite, so we need our opposite and the side that we have information about, which is our hypotenuse. So opposite over hypotenuse. What trigonometric ratio is opposite over hypotenuse? It is sine. So we're going to take the sine of our angle measure, so sine of 26 degrees over 1 equals our opposite, which is what we're looking for, so that's x, over our hypotenuse, 15.3. Again, we're going to cross multiply, so 15.3 times sine of 26 degrees equals x. So x is by itself. We're going to type that into our calculator, 15.3 times sine of 26 degrees. And that gets us 6.70708. Again, we are rounding to the hundredths place. The number after that 0 is a 7. So again, we are raising our score. So 6.71 centimeters is x. So we've found our opposite side of 6.71. We're finished with the opposite side. Now we need to find our adjacent side. And we have adjacent and hypotenuse. What is adjacent over hypotenuse? It is cosine. Remember, we're going to use our hypotenuse, not our opposite, because the hypotenuse is the one that was given to us in the problem. Again, we're not going to use the opposite because we need to find the adjacent. So we're setting this up. Cosine of our angle, so cosine of 26 degrees over 1 equals our adjacent, which is y, what we're trying to find, over our hypotenuse, which is 15.3. Again, we're going to cross multiply, so 15.3 times cosine of 26 degrees equals y. So again, we're going to type that in our calculator, 15.3 times the cosine of 26 degrees. and we get 13.751. Again, we're rounding to the hundredths place. That 5 is in the hundredths place. We have a 1 after it, so we keep it as the 5. So 13.75 centimeters is Y. And our last example, San Francisco's Lombard Street is known as one of the crookedest streets in the world. The road's 8 switchbacks were built in the 1920s to make the steep hill passable by cars. If the hill has a percent grade of 84%, what angle does the hill make with a horizontal line? Round to the nearest degree. So our important information here is that 84%. And we want to know what the angle makes with the horizontal line. So we have a triangle here. That 84%, remember if we change it to a fraction, is 84 over 100. And this is like our slope. It's rise over run. So we'd have 84 going up, 100 going across. And we're looking for this angle down here, the angle that is being made with the horizontal. So remember, label your hypotenuse, across from your right angle. Adjacent is the one next to the angle we're looking for. And the 84 is the side opposite that angle. And when we are looking for an angle measure, remember we're using the inverse, and we need 2 sides that we have information about. The only 2 sides we have information about are the 84 and that 100, the opposite and the adjacent. So what is opposite over adjacent? Tangent. So we're going to take the tangent inverse because we're looking for an angle of 84 over 100. We're going to take that to our calculator. Tangent inverse of 84 over 100. And that gets us 40.0303. Remember that when we're dealing with an angle, we're rounding to the nearest whole number. So our whole number, remember, is the ones place. We have a 0 after that. So we keep our scores. So we have 40 degrees for the measure of our angle.